Example 2. Find an equation for each ellipse, then graph the equation by hand. They give us the vertices at positive 3 and negative 3, 0. So V2. Now you can put V1 over here, V2 over here. It doesn't really matter to me, okay? All right, so we get the vertices. So that means since the vertices is on the x-axis, we know this is horizontally positioned. If it's horizontally positioned, then the x squared should get the a squared. Then that means the b squared is left with the y. I know the center is right in the middle between the two vertices, so we know the center is at 0, 0. They gave us c equals 2. We know a is 3. So a is always half distance between vertex 1 and vertex 2, or the distance from the center to one of the vertices. So that means a squared is 9. If c equals 2, well, I guess I can go straight to c squared equals 4. So let's use Pythagorean theorem for the ellipse. A squared equals b squared plus c squared. A squared is 9 equals b squared. C squared is 4. That means b squared is 5. That is enough for us to write our equation. A squared is 9, put 9 in there. And then y squared over b squared, which is 5, equals 1. That is perfect for our equation, okay? Now we need to figure out where square root of 5 is. Square root of 5 is perfectly in between square root of 4 and square root of 9. This is 2 and this is 3. So closer to 2. So 2 and some change, just like that. Make your ellipse. Try your best to make a nice ellipse. It doesn't always happen for me, but I'm still trying. All right, so that's my ellipse. And I said graphing in the ellipse unit is a lot easier than anything else. And again, I already took my time earlier to make all the tick marks for all 3 examples here, just to save us some time in the recording. So let's go and plot focus 0, 4. 1, 2, 3, 4. So here we go. Here's F1. And then the vertices are 0, 8. Do I have 8 tick marks? If not, I need to add one more. So do 8 right there, and negative 8 right there. So 0, so vertex 1, vertex 2. Okay, so that means the foci number 2 is 4 units down from the origin. Just like that. Okay, now we know the center is at 0, 0, because the center is right in the middle of the 2 vertices, or right in the middle of 2 foci. So if I know the center, which is right here, I know C equals 4 units. But in c squared is 16. I know A is 8 units. So a squared equals 64. Let's find b, because I do need b to find the 2 point for the minor axis, okay? So a squared equals b squared plus c squared. 64 equals b squared plus 16. Subtract 16 from both sides. So b squared equals 48. Now 48, simplify that. I don't need to simplify to write my equation, but I do need to simplify to plot, okay? Let's write the equation first. Center is at 0, 0. So x squared over something plus y squared over something equals 1. Since the vertices are on the y-axis, this is going to be vertically positioned. So that means the a squared is going to go under the y squared. So 64 goes here. 48 goes here. Again, I don't need to simplify that to write my equation. Now I need to figure out where 49 is so I can plot my b minor points. So 48 is here. Next perfect number is 49. And the previous number is 36. So that's 6, 7. So closer to 7. Okay, so I'm going to go a little bit past 7 units. 1, 2, 3, 4, 5, 6, 7. So slightly over here. Not exactly to scale, so don't hold me up. So it's almost near a circle, because if you think about it, the two vertices only go up to 8, and the minus already like slightly, well, that's some ugly one. I'll just make that a little bit better. And the minor axis goes slightly a little bit past 7, so it's pretty close to a circle. All right, let's go do the last one, example dos. All right, centers 1, 2, 1, 2. So center, check. Focus is 1, 4. Focus 1. If you know focus 1, because you added 2 units from the center, you can subtract 2 units to go to focus number 2. Focus 2, just like that. So we got focus. So that means we know C is always from the center to one of the foci. C is 2 units, okay? So C squared equals 4. And it says containing the point 2, 2. So let's go plot 2, 2. 2, 2 is right there. Okay, so since that is directly to the right side of the center, we know that has to be one of the minor points. So if I know that's a minor point and it's 1 unit to the right of the center, the other minor point would be 1 unit to the left of the center. So that means I know B is 1. So B squared is still 1. That is enough information for us to find A value. So A will get us the points for the vertices, okay? So A squared equals B squared plus C squared. So A squared equals 1 plus 4. So A squared equals 5. All right, that is definitely enough for us to write our standard form. Now, okay, so where do we put the A squared? Under the y minus k squared or under the x minus h squared? Hopefully you said y minus k squared. That is dependent on how the ellipse is positioned. Since the foci is vertical, right? That means it's parallel to the y-axis. So that means the vertice will also be parallel to the y-axis. So because it's that, a squared goes here, because a squared is always bigger than b squared in an ellipse. So we have everything we need. H is 1, so minus 1 quantity squared over b squared is 1 plus y minus 2 from the center all over. Your a squared happens to be 5. And remember, this always equals 1. Box that up. Okay. Where is rad 5, right? Rad 5, because I'm trying to look for a value, is between rad 4 and rad 9, 2, 3, so closer to 2. So I'm going to go a little bit past 2 units from the center, just like that, and then a little bit past 2 units from the center downward to say vertex 1 and vertex 2. Just like that. And let's see, did we find everything that it asked? Sounds good. We're done.